Okay, in my previous video, I illustrated how to carry out, or using this particular data set, I illustrated how to carry out confirmatory factor analysis using the AMOS program. So this was the original data set. I had measures of basically survey responses based on 240 surveys, responses to measures of prejudice, contact, intergroup anxiety, anti-inclusiveness, and intentativity beliefs. And basically, each person responded to all of these survey items here on a scale from 1 to 7, 1 being strongly disagree, 7 being strongly agree. And so when I ran the confirmatory factor analysis, this was the basic model that I tested. And essentially, in this video, I'm going to illustrate how to carry out path analysis using these latent variables. So I'm going to test a theoretical model of the relationships among these variables here. So the first thing I'm going to do is actually, I'm going to just kind of create a new workspace. I'm going to click on Save As, and I'm just going to call this Path Analysis with Latent Variables. It's sort of a long title, and then click on Save here. And instead of redrawing everything, I'm just going to pivot off of what's already been done. So the first step is I'm actually just going to delete all of these correlations among the latent variables, because I'm not going to be specifying all possible relationships among those variables. So in the basic model that I'm going to be testing, I'm going to incorporate intergroup anxiety as being predicted by prejudice, then prejudice as being predicted by contact, and then anti-inclusiveness being predicted by both intergroup anxiety and prejudice. So basically, like I said, when you're running path analysis with latent variables, the first step is basically running a CFA, or confirmatory factor analysis, and which is also referred to as a measurement model. And that model is, you test it out for fit, make any modifications that's necessary, and then you pivot off of that model when drawing out your paths among your latent variables. So in this particular case right here, I am actually going to, since anti-inclusiveness is my ultimate outcome variable, I am actually going to move this downstream. So I'm actually going to highlight all of these parameters right here. Actually, the first step is what I'm going to do is I'm going to rotate these indicators around. So if I basically I clicked on this little button right here and rotated them around, and actually I'm going to put them down below to give me a little bit more workspace. So now I'm going to select one object at a time and just basically move each of these. So you can see that basically these are all turning blue, which indicates that I have selected these objects. So now I want to move this over here. So I'm going to actually click on this little moving truck right here and move it over this area, as you can see right here. And the next step is to unselect. So I'm going to deselect these. And I'm actually going to go ahead and include a prediction error term for anti-inclusiveness. So this little box right here, I'm going to click on it and highlight it, and this is basically a disturbance term. It's basically variance unaccounted for by the variables that are going to be used as direct predictors of this one. So actually I can move this around as well just by clicking on it. So now I am going to right click and go to object properties, and I'm just going to call this go to text and just call this D1 for the disturbance term. So the next step is I'm going to move anxiety and prejudice to be more proximal here. I don't have to do this. I could, but I want to keep this kind of clean. So I'm going to again, I'm going to select one object at a time, and I'm just going to move these. Just going to kind of clean up my little prejudice variable and make it a little bit more proximal to this variable right here. So I'm going to use my little moving truck and move it over here. And so as you can see, that's where it's going to look or appear. Deselect, and I'm going to do the basically. I can also kind of rotate these as well, but you can see it kind of goes off the screen right here. Just to kind of give myself, again, a little bit more workspace, I'm just going to deselect, and now I'm going to just select all objects and use the little moving truck, and I can drag this down, and you can see it's a little nicer looking. So now I'm going to do the same for anxiety. I'm just going to select one object at a time, and basically highlight all of these boxes and arrows, and basically use my little moving truck, drag it over, and bring me here, and then I'm going to deselect, and I'm just actually going to rotate this around as well. So you can see that that's one of the nice things about AMOS is that the drawing program gives you a lot of flexibility in terms of moving things around and kind of cleaning things up. So now I need I'm going to have prejudice and anxiety as being predicted by contact. So I'm going to need error terms for each of these latent variables as well. So I'm going to click off of the rotate, click on this little add unique variable, and so I'm going to click on it and just kind of rotate it around a little bit so I can do that. Same for anxiety. And so now in this particular case, I am going to I'll click off of this and then right click on the little circle here, and I'm just going to call this D2, and this one I'm going to call D3 for disturbance 2 and 3. So the reason why these are here is because these variables are being treated as endogenous in the model. So endogenous latent variables. So now I'm going to draw my my errors to reflect my causal prediction. So I'm going to have prejudice predicting anti-inclusiveness here, anxiety also predicting anti-inclusiveness, anxiety also predicting prejudice, and then I'm going to have contact predicting anxiety as well. So I'm going to stick with that for this particular model. And so now at this point, I've drawn out my model. I want to save it, and then I can go under Analysis Properties. And in the previous video, I indicated that I had some missing data, in which case we're going to use full information maximum likelihood in AMOS. So I have to click on Estimate Means and Intercepts. If there was no missing data, if I had a complete data set, then I would click off of this, because there are certain things that you can't get in terms of output when you click on this. But if there's any missing data and you don't have this click, the program's not going to run. So I'm going to click on this. Under Output, I'm going to ask for standardized estimates, squared multiple correlations. I could ask for indirect, direct, and total effects, and so forth. So there's a number of options that are available to you. So now I'm going to click on the little X right here. I'm going to resave this again, and now I'm going to click on this little box to run calculate the estimates. So now you can see I've got a chi-square value, degrees of freedom, and if you go, you can see if I toggle right here, you can get the unstandardized and standardized estimates. So you can see that as I said in the previous video on confirmatory factor analysis, I'd set the scale of my latent variables in relation to one of the indicator variables, and so the paths that were fixed to one are not being estimated, whereas the remaining paths are being estimated. If you click on standardized estimates, then all the paths are being estimated, and basically the scale of latent variables is fixed to 1. So at any rate, using the unstandardized estimates, the path that you see right here, this would be interpreted as an unstandardized path coefficient from contact to anxiety, and then from anxiety to prejudice. And so all of these paths right here, reflecting the structural relations among the latent variables, are basically unstandardized. When I click on standardized estimates, we would interpret these at pretty much along the lines of standardized regression coefficients. So with unstandardized estimates, they're interpreted largely as unstandardized regression coefficients. With standardized estimates, they're being interpreted along the lines of standardized regression coefficients. So at any rate, I can click on this little box right here to get my output, and you can see under estimates, we have, we have in this little portion right here, we've got the relationships, the predicted relationships between among my latent variables. So I have contact going to anxiety. This is the unstandardized regression weight or unstandardized path coefficient. You can see that that was statistically significant. Anxiety predicting prejudice, you can see that it was not statistically significant. Prejudice predicting anti-inclusiveness, that was not significant. But anxiety predicting anti-inclusiveness, you see that that was statistically significant. The remaining coefficients, where you see the ones, these are where we fixed the scale of the latent variable by using one of the indicator variables. So those are all fixed parameters. But the remaining path coefficients, you can see, were all statistically significant. So at any rate, when we scroll down, you can see the standardized regression weight. So like I said, these right here, prejudice to each of its indicator variables, contact to its, and so forth, these are basically standardized factor loadings when we're looking at this. And these would be interpreted as the standardized regression weights or standardized path coefficients. So we interpret this pretty much these values as we would with beta coefficients in regression. So you can see this is the relationship between contact and anxiety, anxiety to prejudice, prejudice to anti-inclusiveness, and anxiety to anti-inclusiveness. Scrolling down, we have the squared multiple correlations. For each of our latent variables, anxiety, prejudice, anti-inclusiveness, these basically are those variables that are downstream or endogenous in the model. So the predictors of anxiety accounted for about 7% of the variation. It's a proportion, basically an R-squared value, and we just multiply it by 100% to get a percentage. So we accounted for 7% of the variation in anxiety, basically 0.7% of the variation in prejudice, and about 16.6% of the variation in anti-inclusiveness. The remaining values would be the communalities from the CFA portion of the model. When we scroll down, we have different matrices. So we've got matrices of total effects. So these are basically unstandardized total effects, standardized total effects, the unstandardized direct effects, and standardized direct effects, and indirect effects. Basically, so when we click under estimates, we get all of this information. If you want to look at things more specifically, you can just click on, you have your scalars, which is the regression weights, intercepts, variances, squared multiple correlations. Under matrices, you get, the various effects as well. Notice that you don't have any significance tests for these effects. That's because we didn't ask for, basically to generate those significance tests, we have to use bootstrapping, and to use bootstrapping in AMOS, we have to have a complete data set. So, if we go back and we look at this, basically under analysis properties, if we go to bootstrap, we could theoretically ask for confidence intervals that would be utilized in interpreting the indirect effects. But again, we have to have a complete data set, and so whenever this box is checked right here, we can't do that. So basically, in interpreting the indirect effects in this way, we can only utilize it from a more descriptive standpoint. But if we want to actually carry out significance tests of those indirect effects, we'd have to use bootstrapping, which would probably entail generating a full data set, maybe through some imputation strategy, and then requesting the bootstrapping option. So at any rate, basically, if we go back to our data, our output file under estimates, this is what we just covered. If we go to model fit, these are the indices that are utilized to assess the overall global fit of the model. So there are various indices that can be utilized. The more common indices include the chi-square goodness of fit test, the comparative fit index, Tucker-Lewis index, and the root mean square error of approximation. There are others as well. These are all different lenses by which you can look at the fit of the model. Basically, in terms of interpreting the chi-square test, this is your chi-square value and your degrees of freedom for the analysis. And what you're looking for is a non-significant p-value for that test. So basically, you're looking for a value that would be, say, greater than 0.05. The chi-square test is oftentimes kind of referred to as a badness of fit test. So statistical significance for the test would actually indicate that you have poor fit of your model to the data. And so in this case, we do have that occurring. The one thing to keep in mind about the chi-square test is that it is sensitive to sample size. And so with larger sample sizes, it's easier to find statistical significance. And given that SEM is a large sample technique, it can be the case where you have you can have a significant chi-square value, but other indicators of fit are suggesting good fit. By the same token, it's also possible that you could have, if you happen to have a particularly low sample size, this not be significant, and the other indicators indicating that you have poor fit. So it's generally a good idea to look at both the significance test and also the other more descriptive indices to see how well the model is fitting the data. And so you can see right here, with comparative fit index, Tucker-Lewis index, you're looking for values that are above 0.90, preferably above 0.95. You could say 0.90 is sort of a minimum threshold for suggesting a good model fit. Values that would be above 0.95 would be considered particularly good. So in both of these cases, this is indicating that we have a particularly good model fit to the data. When we look at the RMSEA value, or root mean square error of approximation, we're looking for values that are optimally below 0.05, and values that are below 0.08 would be considered acceptable. So basically, the RMSEA value and the comparative fit index and Tucker-Lewis index, both of those are suggesting that we have good model fit to the data. It is important to kind of go back and look at our. So in terms of global fit, we have good fit to the data. So like I said, our model fit statistics suggest we have good global fit to the data, but clearly, this path from anxiety to prejudice is not significant. The path from prejudice to anti-inclusiveness was also not significant. So, in theory, those might be considered paths that we might prune in the future. And let's just for argument's sake, let's prune them out just to see what happens. So anxiety to prejudice and prejudice to anti-inclusiveness. So in this case, I'm going to go back. So I'm going to go anxiety to prejudice. Go back here. Anxiety to prejudice and prejudice to anti-inclusiveness. So I'm just going to click on that here. And for argument's sake, let's add a path from contact to prejudice. So and see what happens. So with this model modification, I'm actually going to rename this file. I'm just going to call it, go to File, Save As, and I'm just going to call this Path Analysis 2, and save it, and basically keep everything as is, calculate the estimates, and see what happens. So basically under estimates, basically contact to prejudice, that path was not significant. The model fit basically is essentially the same as what we had before. So at any rate, like I said, you have various output options. Like I said, we can't ask for bootstrapping if we're estimating means and intercepts. And under output, if we want to see what further happens, if I click on modification indices, which is basically gives you some empirical approaches to looking at adding in different parameters within the model. If you click this button right here, you can see what happens. If you click on this, try to estimate, you'll see an error as well. So again, it says modification indices cannot be computed with incomplete data. So basically, you would have to ask for bootstrapping or get modification indices and so forth. You would have to basically ask for um, um, you'd have to have a complete data set and not have this little button checked right here. Other possibilities in terms of model modifications, one possibility might be, well, let's see if this error term might be related to this error term. We could certainly model that as well and test it. I have no theoretical reason why that should be related, but basically, you can specify possible relationships among error terms within your model as well. So at any rate, this basically just gives, like I said, a very brief overview of using AMOS drawing program and carrying out structural equation modeling using latent variables. And like I said, the first step is basically carrying out a confirmatory factor analysis, which is what I cover in my previous video. And basically determining whether the measurement model, how well it fits the data, making any kind of modifications that are necessary in order to improve model fit, and then carrying out testing out the structural portion of the model, where we're testing out predictive relationships among latent variables. So that concludes this video in this series.